Hi everyone, thank you for coming to this talk. My name is Natalie, and today I will be talking about Rust module system. My talk expects that some of you are already familiar with basic Rust project structure, and this talk will be sharing more about larger projects. How do you manage them? What kind of tools you can use, and how do you make it effective? This is all their laptop. Shall I just use this straight? Oh, I see we have two connectors. Is that working? Okay, so we'll start. So I'm Natalie, I'm a staff cloud engineer, so primarily working on infrastructure, using different programming languages for my work. One of them happened to be Rust. My LinkedIn will be presented at some point, but I'm sure you can easily just Google.
Mirror your display, or just slide it? You have it extended, like a second monitor. You go to displays.
Mm-hmm.
Can you help?
Sure.
Sorry. That's it.
Oh, that's great.
Thank you.
Sorry, now it's becoming a bit hard to. It's hard to see. Okay, cool. So here's the information, and let me just do one quick thing. Yes, so let's continue. All right, so Rust. So agenda, sorry, I don't know, how do I click this? Okay, agenda for today is basically talking about modules. How do we optimize the larger projects? I can share some tooling around that, and okay, sorry, this is confusing. Okay, so whoever used Rust previously probably familiar with the module structure. This is a super simple example when you have ellipse module type and you have two modules, and you can assume if you work in large organizations, you probably go into the module hell experience where you have a lot of different modules. They sometimes have circular dependencies, sometimes they not. And then in some cases you have different packages, sometimes you have workspaces, and at some point it's becoming hard to manage. But there are different challenges with that, right? Let's say in our experience, you can solve them differently, and the whole representation of this talk depends what are you optimizing for. So here, the basic module syntax for people who never saw Rust. Basically, you can have public module, you can have private modules. We have a small pub word and small mod word just to define if it's public, if it's module. You can have functions with the module, they can also be public, and things like that. So this is a basic syntax, and I think this should be enough to get you an idea what we're working on. And, oops, sorry, it's just a bit hard. So concepts. Modules are units, right? They are more like a logical unit where we define what we want to place in it. It contains different types, it contains different functions, things like that. It helps us to control all the privacy of our items within the module. Crate is the unit of our compilation and linking. So linking dependencies within crate and creating an executable library with different types. Package is not something that we define with the code, but for the packaging, we're using Cargo. That's the most common tool. And Cargo allows us to manage packages, publish them, things like that. And it's kind of like a unit again of our software distribution, the way how we're managing our packages. Could be internal packages, it could be open source packages, so there are different types of them. And the interesting part that is also helps us with the larger projects, our workspaces. The workspaces is like if you think about it, it's a different set of packages. And with workspaces in Cargo, we can manage different packages in different ways. We can exclude them, we can have different commands. My next slide should represent that. So this is what, basically with the Cargo project, with any project, Rust project, you will have a Cargo toml. And with the Cargo toml, you can have different settings, right? And I would recommend reading the documentation, how you do it, because it gets pretty much, it gets heavy because you need to have a project overview. But when you go into the larger scale, this is the approach you should be using. Now, when we think about project structure, right? Let's say you start small, you build some tool, it became useful, now you're iterating, maybe you added some helpers, they become certain libraries, certain packages with your code, and now you're thinking, how do I grow my project? What do I do? Do I start approaching my structure from the point where I have a lot of large packages, but I have very few modules, or shall I just have a lot of different modules that have different functionality? And that's where it's becoming challenging in terms of you need to define that before you start. It's good if you can define before you're building your code, right? So in the future, you have to deal with less refactoring of your code. And by looking at all the different practices within the community, I can say that usually when you have larger packages with many different modules, there are different there are cons and pros, obviously, and again, keep in mind that we optimize on specific things. So this presentation is built in a way that you have a large team, and for example, your compilation, your test takes forever, and you optimize in this case for compilation time. So let's say if I have a fewer packages with my, the dependency management in this case becoming crucial, as well as versioning, which is also can become pretty heavy. So you have larger packages with different modules, and you have to have different Cargo tomls and all of them, and you need to understand how versions are playing a part. Then let's say if you have package versus module, and you refactor in your code, it's easy from your module file or main to remove the module, versus when you have to remove the package, because most likely your package will be already reused, right? And it could be, again, cyclical dependencies on a package when you cannot just remove the package because the rest of the code can be affected. So you need to keep that in mind. So far, by this slide, I'm showing that working with modules in certain cases are easier versus when you have many small packages. But with the smaller packages, if you think about your code structure, you get more modularity, so you can achieve things in a certain fashion. Your reusable parts they will have a full circle of the code CI, let's say it this way. Because, as I mentioned, packages is something that we manage in the Rust ecosystem with specific tool, so you will need to publish it properly. You also will need to have a full test coverage, most likely, things like that. And of course, when you have different packages, you need to make sure there is no redundancy, because let's say basically just keep in mind that there is a redundancy. And here is an interesting point that when you have a huge, large package, of course, it takes time to compile it much longer. So the advices I have for this talk is what we can do simply, right? Split your dependency groups. Think about dependencies, eliminate them if you can. Use generics with your code. It's it's easier to build the reusable code more in a generic way, which can later help you to build smarter code and eliminate dependency, like I mentioned before. Think about runtime versus compile time polymorphism. There is also explicit dependencies. We usually have duplicated dependencies. And I know in Rust, you can have your tests within your production code, let's put it this way, right? But when you think about larger teams and different code bases and how long your test might run, it's actually makes sense to put them in the separate files and managing them separate. Now let's look at each and every suggestion specifically. So if you want to see the example of how do you split the dependencies, on this slide you can see that we have simply a module called services, and we can spread this module into different modules. It's easy, right? But in the future, if you have to, let's say, eliminate product management and you don't want to use it, it's pretty easy to just remove the whole module, simplify your code, and the whole code will look simpler. Okay, sorry, it's just hard. And then if we're talking about generics, this is an interesting part because when you have different dependencies with your code, right? And in some cases, like I said, they can be circle, they can be regular dependencies. And let's say you have, I have a good code example here. Let's say over here you have just a usual query, right? And right here. So in this example, you have just simple module user that basically uses the query from the database module. And then you can, let's say you want to make some modification. It's pretty hard in the first example to make it adoptable for other code requirements maybe moving forward. For the second example, when I add the generic for my trade, so I will create trade database, I will create my find user method, right, or function, and then in my module, I will just reuse it. So then that means that my module is no longer dependent on the query struct from the example number 1. And then the second trait which I added makes it more generic if I need to add any modifications, if I need to play with the code. So it makes it more flexible. Even in the future, if I have to refactor it, or if there's if I want, in my query, I want to add another query or make it more complicated, it's easier to do it with a trait. Again, we can define different types there as well, which is pretty handy in this kind of situations. There could be a question like when you just started writing your code versus when do you need to start thinking about traits when you start growing your code base? A simple example. If you have this specific small example when you have, let's say, one function and you're never going to have another function. This is very basic, right? But just think about it. Sometimes you have a specific use case, then you don't expect a lot of different calls to the database, for example, right? Let's say you're building some specific APIs, and that's like there will be only user login and maybe user logout. For that specific login, and you implementing module auth, right? So in that case, you know that your module auth authentication will have specific functions only. So in that case, you probably will be fine with the top. But let's say if you know that you're going to grow the login options, maybe you will add SSO or something else. So your auth, the whole structure of that will be changing. You probably want to start thinking about traits and making it more complicated. And then the other part I mentioned, when you think about runtime polymorphism versus compile time polymorphism. Compile time is very static, right? So it involves a lot of complexities because you have to have a larger, heavier code which will be solved all during the compression when all the elements of your code should be there at the compile time. It's actually more performant. Obviously you get more types kind of safe when you're thinking about the logic and the structure. So when your code will be compiled, and then during runtime you need some specific type, you will get it on the fly, right? Last point here, it's pretty much good use if you're trying to reach for performance of your code, or if, let's say, you're working on some specific safe projects. Because we all know, like with modules, we get this public versus private option, which gives us more security and safeness. But let's say if you're building a not so complex, simpler application, you probably want to also consider the runtime polymorphism, because in that case you're getting lighter code, so compiling it will be faster, obviously. Obviously, less binaries will be in the code. You're actually building the code in a way that you're thinking what kind of things, structs, types you will need only during the runtime. So you're kind of thinking about everything, or every object, every part of your code, and you know, like when you build in the code later, you know what kind of implementation is there. And think about, like, from the previous example, I showed the example of trade, the benefits of it, and then you can have a dynamic dispatch with that code when you're actually using only things you need to define. And usually it's pretty easier when you have a shared code for a person to look at the dynamic trade and just understand what is it about, versus if from the previous example of the code, when person, let's say, not familiar with, oops, wrong way. When a person is not familiar what they're supposed to, like, imagine if it's a large file, it's hard to understand what is it. It's really not that detail specific. Like in this type, user, by just reading, your teammate or your company engineering team can easily understand what's expected here. So basically, good for flexibility, pardon me, or like I said, in my opinion, when you have a teams and you want to share the code base, it's pretty easy because you have specific components of specific functionality. Here is a pretty large example. On the other slide, I'll make a bit of a break what we are looking at. But most cases, your code will look pretty much the same, right? We have a logger, we have application, and then in this part, our application, sorry, I thought I can, basically line 19, you can see how logger is used during your compile time, versus this slide is probably, I just want for you to see the difference. So the line 19 here and the line 21, I guess, that you can see the application definition. So this is only the left part of the slide. It's just hard to represent it this way. You can show it with the IDE, but again, it will be super small. So basically, you see that here we on this side, we have a trait. We added dynamic dispatch, and then we can see that through entire application code, we have different types of loggers: file logger, console logger. Create as many loggers as you want, and then they all can operate on the same instance by using specific types, and only during the runtime for specific logger we will define the type we want to use. So it is flexible. Again, probably from type safety or performance, it's not that efficient, but for specific application, it's actually pretty good. And I'm just trying to change my slide. Explicit dependencies, I guess we're all familiar what this means. But again, when you work in a big, gigantic code bases, look through your dependencies, understand what they are. Obviously, in Rust, we have different global variables. I do not recommend to use them some cases you should, but again, in the larger code bases, it's just impossible to keep track of all the changes, all the variables. So just in this example, instead of using super on line 7, completely can be eliminated, right? No need. Makes it easier. And again, person looking at the code understand what happens here versus keeping attention what was defined on top of your code hierarchy. And again, when you're importing something, it's pretty easy. You can use export with Rust for all the things. The duplicate dependencies, I'm just going to quickly run by. We all know that we should not do that. It could be hard when you have different packages, right? But there are tools that I will mention in the end of this presentation which actually help you to find them. And then unit test. Pretty much, I think this is pretty good. Spend time refactoring your tests. Use different files. Use like kind of logic of having your tests in a module separately, run them separately. If you have a like gigantic code base between teams, maybe just spread them in a module where every team has their own test. For specific function testing or unit testing, depends what you want to cover. And here are some helpful tools. Rust Analyzer is pretty good. Cargo modules actually show you, like this is on the right side. I just wanted to show you when you're confused, what kind of dependency you have, what modules is using. You can have graphs like this, and the GitHub page is pretty good of showing different commands versus what kind of graphs you want to get, and then you can see the duplicates easier. Cargo Machete is like, I think it's 2 people, open source project. It's supposed to be temporary project, but it grew so far alive, I think because the main code for Rust still doesn't have all the functionality. And then Cargo Audit is just if you're building secure projects and things like that, you just want to use that tool in order to understand what dependencies are there, how they affect each other, and how your code is actually using them. So this is it. I think I was on time. So the summary is understand the difference between all the options you have. For the larger code bases, think about workspaces. Learn, it just takes 5 minutes through your Cargo toml, how you can import your dependencies in your project, exclude them, include them, depends on the situation. Don't forget that you can run different profiles. Don't forget that sometimes Cargo compile your code with different profiles, and your dependency can be reused, which is tricky. That's why Workspaces is a good solution for that. And yeah, I hope you learned something today, and thank you for your time.